Hello, good morning, everyone, and welcome to this virtualization webinar. My name is Beatriz Ortega, virtualization business developer in EMEA for telco industry. Today, we are excited to talk about Openshift Virtualization and how it offers a significant opportunity to modernize your existing virtual machines infrastructure. We know that many of you virtual machines virtual machines are critical part of your IT landscape, and it's our goal today to show how we can bring the benefits of modern cloud-native approaches to those traditional workloads. We are lucky today because we have in this webinar Federico Nebbiolo, our technical architect for virtualization with huge experience in telco market in EMEA. Say hello, Fede.
Yes, Bea, thanks. Thank you, Bea, and good morning to you, and good morning to everyone. Again, also from myself. And yes, today we are talking about Openshift Virtualization and how it provides a way to manage virtual machines directly within Openshift. For those of you who already know the Openshift container platform, we will be able to integrate VMs into our Kubernetes environment. And so we will be able to apply the same declarative management, automation, DevOps practices. We will see some demos today as well, to use containers and virtual machines at the same time, streamlining your operations and modernizing the underlying supply chain for those virtualized environments.
Good. So we are planning one interactive session, beginning with a brief introduction to Red Hat virtualization approach, and moving later into a technical overview of Openshift virtualization, covering its key functionalities from a market perspective, and addressing the main challenge that our customer face. That is the idea. So let's go ahead. But let's start just exploring why this topic holds significant interest for the infrastructure industry, particularly for telco companies. Telecom customers have got a great momentum right now to decide on how they want to shape their future in virtualization infrastructure. So our customers actually are seeing significantly less flexibility and higher costs with the current providers that are dominating this space for very long time. And at the same time, the business is asking for ways to grow much faster, to provide better performance, adopt new technologies such as artificial intelligence and serverless, for example, and manage global risks and do a consolidation and extend to public cloud and reduce dummy tasks, increasing the automation, of course. And these challenges are exactly what Openshift aims to fix. Actually, let me say let me later if we are just covering these topics. Thinking about past 30 years in the industry, the view is of legacy and heritage application on the bottom half, and how we foresee the progression of converting those workloads to a thoroughly cloud-native application. The point being is that that transition is not going to happen overnight. It will be evolutionary and not revolutionary. And in many cases, some workloads may never make that transformation. The reasons may vary. Why fix? What's ain't broke? I have not budget today, or is not covered in the roadmap of my vendor, and all of them are unstable reasons. But in some cases, it will make sense to transfer applications. Application modernization is all about the digital transformation of your legacy and heritage application to enable them with new capabilities and deliver them quickly. It's about improving developer productivity and increasing the efficiency of operations by enabling and enhancing DevOps capabilities of your organization. All of this to drive greater speed to market with flexibility and increasing innovation, maintaining the cost saving. That is the main goals that we mentioned it before for this. So new feature will be added to existing applications. coexistence will involve new and legacy applications working together. And the target is clear. Microservices architecture fully exposed to new and legacy applications. And while containers offer a unified application platform for modern applications, many organizations still face the challenge of managing diverse environments. The virtualization story has been going very strong for several decades, where some vendors, as VMware, pioneered the idea of running open systems in virtual machines, transforming the entire industry. We are now in the second step, where customers are running this virtualization platform with virtual machines on top, but also deploying a container platform, Openshift, for instance, as a second platform. And the idea is we are moving now with Openshift and Openshift virtualization is the third stage, is where the container platform itself is the hypervisor, Openshift environmental with virtual machines, part of the key edge platform, having multiple benefits. All virtual machines are exposed, if needed, to containers within the cluster as they live together as one. And all abstraction that Openshift presentation for containers, such as storage or networking, is available now for virtual machines. But what is Red Hat Openshift virtualization? So getting back to our previous diagram, showing the unified platform, I understand that we can run virtual machines which are not going away overnight, alongside with containers that are rising in the adoption also by providers and telco application vendors. Some application might even build on both, with some containerized elements and some long-running virtual machines. That is clear, Fede? Do you think I was explaining right? Anything just to add here?
Yeah, no, I think that you did a great job presenting this unified platform. I have the first teaser for this interoperability in the following screenshot in our slide deck. And we can see for those of the attendees who are already familiar with the OpenShift web user interface.
Please do it.
As we can see here in this screenshot here, that the web user interface will be exactly the OpenShift one, and the virtualization tab will appear together with the management of the containers in the same panel. So you will be able to manage the virtual machines and the containers in the same way. I think that this is a great advantage for people who are going to manage that kind of transformation that you were mentioning there.
Indeed. Okay, so the friendly interaction and user interface, I think, is essential in order to do more operative this platform. Where is come from? Okay, Red Hat virtualization proposition. Like in Red Hat solution, it is originated in the open source community. Really, it is based on one upstream project that is Kubernetes, right, Fede?
Yes, exactly. It happens for all the products that Red Hat provides. They come from the community, they come from the upstream projects. In this specific case, OpenShift Virtualization is powered by KubeVirt, which is an open source project that was initiated in 2016 by Red Hat, and it's written mainly in Go, as most of the operators available in the Kubernetes environment. Now it is a CNCF sandbox project, and it received contributions from various companies, including NVIDIA, for example, for the GPU support.
Yeah, but really a long time ago, 2016. And it is a well-supported and actively just developed project.
Yes, exactly. Absolutely. The goal of the KubeVirt is to allow VMs to run VMs together with containers and providing them as a single control plane. So the contributions are for different vendors, different community members that want to run that kind of workloads in a containerized way.
Good. So looking at the contributor over the last 6 months, you can see that Red Hat is a significant contributor. But as you mentioned it in NVIDIA, there are many others company and independent developers actively just contributing, showcasing the strong community behind KubeVirt. That means innovation and proactivity are key drivers behind this commercial solution. But not all our customers are in the same page and they have the same circumstances. Customers considering Openshift virtualization are typically looking to either use to migrate of the current traditional virtualization platform or to modernize by transforming to containers, but also to run virtual machines in a more modern way. So most customers are likely just to prioritize just VMs migration from the current provider over VM modernization. For this customer, Openshift Virtualization Engine may meet their needs. Openshift Virtualization Engine is a specific streamlined product edition of Red Hat OpenShift designed exclusively just for virtual machines workloads. There are other customers interested in virtual machines modernization that can use OpenShift with the core of virtualization functionality to gain a unified application platform to run and manage container and virtual machines-based application workloads side by side. This feature allows users to take a cloud-native approach to virtual machines, okay? That is enabling the migration of existing traditional virtual machines and the deployment hybrid cloud infrastructure platform. Red Hat OpenShift Enterprise Application Platform, for instance, okay? Fede, was it well described?
Yes, I think that indeed there are this dual approach that every person interested into OpenShift virtualization can do, and they can do with their own sales or technical content to better describe their goal and their expectation. My key takeaway here is that in any case, since the technology is the same, the underlying technology is the same, you can start with the simple migration that you described, so the migration from the existing VMs to other VMs, just as a lift and shift, with a lift and shift approach. But at any time, you can just switch to the augmented platform, the full OpenShift container platform, to also include containerized workloads and to start migrating to containers as well.
Great, that can be a journey. Okay, as we were saying, yes, evolution, not revolution. That's right, okay? So good. So in order to be sure, let me, in summary, just show you the key advantages that we obtained from OpenShift virtualization. First of all, unified management. As mentioned before, customers who use OpenShift virtualization and OpenShift can manage containers and virtual machine workloads all within a single OpenShift console, reducing complexity and streamlining the operations. Second, simplified migration. That means a streamlined process to migrate existing VMs to containers that use for instance, the migration toolkit that we have for virtualization, MTB, and I'm quite sure that you will talk later about the migration, to facilitate a gradual transition to containerized application. We will have faster time to production because with OpenShift virtualization, developers can build, test, and deploy workloads quickly on a consistent platform, accelerating application development cycles. We have the hybrid cloud support. By using OpenShift virtualization, customers benefit from seamless integration of virtual machines across different cloud environments. Doesn't matter if it's at the edge, doesn't matter if it's in the core, doesn't matter if it's even in a hybrid clouds, okay, or in public clouds. Of course, we have enterprise-grade security. OpenShift virtualization inherits robust security features from OpenShift platform, including role-based access control and a comprehensive security policy that we are using in OpenShift. And last but not least, DevOps integration, built on support CI/CD pipelines and DevOps practice, enabling efficient application development and deployment. Hopefully, everything will be clear after your functionality explanation later. Fede. So this brings us the core message of OpenShift Virtualization. It's about providing a single unified platform for all your workloads, whatever they are, traditional virtual machines or modern containerized application. Agree, Fede?
Yes, exactly, Bea. I think that with these features that OpenShift provides, you are enabled to manage both VMs and containers in a hybrid cloud environment. And as this slide presents, it's a way to modernize the supply chain and also include the application platform management and the AI platform. So maybe this is a teaser for future versions of this webinar with with another topic. But yeah, I think that for today we will stick to the OpenShift virtualization, not to introduce too. So
second
please move
webinar
on.
very soon.
Yeah.
Good, amazing. So the commercial offer, I think it was we talked about it yes before, but when it comes running virtual machines with Red Hat in your data center, you have a couple of primary commercial options, and that was briefly just mentioned it before. We have Red Hat OpenShift Virtualization, right, which allows you to build virtualized environments within your OpenShift cluster. It enables the management of virtual machines in an hybrid cloud environment. And there is also Red Hat Virtualization Engine on the left, which is a virtualization-only platform designed to simplify virtual machines migration and offer a cost-effective alternative for organization, primarily focuses on running and managing virtual machines. So as Fede was telling before, that is not, they are not isolated products, okay? You can start with the virtualization engine and just go very easily just to work with OpenShift with the core of OpenShift virtualization in order to maintain your virtual machines there. Let's go ahead. Red Hat excels due to our deep roots in the open source community, as we were talking with the Kubernetes, but especially to our expansive partnership ecosystem, empowering us to deliver optimal enterprise solution wherever needed. This principle is fundamental to our virtualization offering, supported by collaborations with the leading partners in this ecosystem. You can see here that we have amazing numbers of vendors just in the storage area, backup and disaster recovery, networking, or cloud services. Okay, so the power of this solution is not because they are vertical; it's because they are open, and we are special sensitivity in order to work with partners, okay, and with the best partners that are part of your ecosystem. But it is proven, it is proved, there are customers relying massively on Red Hat virtualization to ensure their successful implementation. Superior performance and scalability are paramount, not just individual very good feature. During the last Red Hat summit, several large companies shared their experiences demonstrating how they are relying on Red Hat virtualization for modernization at scale. Two examples, very good examples, were Ford and Emirates and NBT, that is one bank, that are clear examples about how they are relying in this OpenShift virtualization for the VM modernizations platform. So NVIDIA relies on Kubernetes. We saw before that they are just active contributor to develop real-time 3D gaming solution globally. Globally, in that case, means very, very huge platforms, okay, in order to cover more than 28 millions and more than 100 customers, countries. So remember that Kubernetes is the upstream project for OpenShift virtualization enterprise solution. So the capacity is there. While this looks great on marketing slide, I believe it will be more impactful just to discuss the functionalities and technical capabilities based on telco market feedback through Federico Eyes. Please, Fede, tell us three, no more than three, of the main strengths or customer considering our platform.
Oh, yes, but I think that we saw many use cases and many customers compared to not only to the ones that you just briefly presented in the previous slide. And I think that the main strengths that customers realized and discovered for our platform stands out in the easiness of provisioning. We will see something later with the easiness that OpenShift Virtualization grants to provision virtual machines and customize them, for example, with Cloud Init, or to customize that with specific networks and storage requirements. This means that you have less manual effort and faster time to get workloads up and running. The second one, for sure, is the reliability. You already mentioned the proven stability of the KubeVirt project itself for the virtualization, but then also the integration into the Kubernetes framework. So inheriting the robust and intrinsic high availability and self-healing capabilities of the Kubernetes orchestrator. And the last one, I think that for customers that want to automate the management of virtual machines is the GitOps approach. At any time, you can decide to automate VM image builds and updates and deploy VMs directly from code repositories, Git repositories, for example, and manage networking and storage in the same way, in the same declarative methods, so that you can define and have a single source of truth in Git to deploy all those kind of resources. Then
amazing.
Adding, yeah.
But
I think
Fede,
no,
perhaps can you show us the technical functionalities OpenShift Virtualization has behind these strengths, okay? Otherwise, we will be taking notes just all time.
No, you're right. You're right. I was taking, I was going too deep in the technical discussion right now. So I think that we can go one by one and see them in action in our live environment. Let's do that. So let's move to the VM provisioning, first one. Okay, thank you. And you can see here a sample screenshot of the provisioning. I think that you can see that or not.
Yeah, we can see.
Ah, okay, we can see. Okay, cool. I thought I lost the visibility for the slides for a second, but I think that from this screenshot here, you can see that from VR provisioning, the web user interface, again, this can be done also through the API and the CLI, presents the possibility to customize, to fully customize the VM details coming from external templates, externally provided templates, for example, selecting a predefined software-defined network or a different storage, and then you can customize it. And we can customize both with Cloud Init, mostly Linux virtual machines, or sysprep for Windows workloads. That can be inherited from the template. The VM can be further customized. We have many other settings and tunings, for example, to select affinity and anti-affinity rules to place our VMs where we think that it's better to place them. I think that it's time for a simple demo around that.
Yes, please.
Just to show how easy it is to provide a VM. It's a very short introduction, so you won't have time to, it will not take us very long, and we will start with a simple demo here from a VM provisioning. This is a well-known OpenShift web user interface, and we present a catalog of available virtual machine templates. We have some predefined ones. You can customize the templates and the visibility for different groups of users, different tenants, different projects, so that the infrastructure administrator can customize the kind of templates that are available for end users. Then each virtual machine can be further customized, as we were saying, for example, customize the Cloud Init configuration to provide the initial password, the storage. Then, as another example, also the networking here. We are just using a simple networking for this demo, but you can customize it further. And then you can also select, as I was mentioning, the scheduling. So, for example, you can schedule your virtual machine on a specific set of worker nodes. And as soon as you're ready, the virtual machine will start. We will provide another example also for a Windows virtual machine. The customization is the same, but for this specific use case, we will start with the default values. And in a couple of seconds, we should see our virtual machine up and running. We can open up the console and access our Windows virtual machine. After that, we can log in and perform all our activities in the virtual machine that has just been created. We have for each tenant, each project, a dashboard presenting all the virtual machines that are up and running, and many other details about the memory consumed, the storage consumed, the resources that has been utilized by our VMs. This was very, very short, but very, very significant to show the easiness of the virtual machine itself. I think that we can now move back to the presentation for a second. And I think that we have to move.
Yes, let me manage.
Okay. I think that we are in the right. Yeah, we show the provisioning. Just to show another view here that we did not see directly in the quick presentation, but one of the key benefits that we mentioned, and we can see another example live here, is the ability to use VMs and containers seamlessly together. So virtual machines that are connected to pod networks are accessible using the standard Kubernetes methods, like, for example, service, routes, pipelines, network policies, to better customize the access to our VMs. So they behave exactly as application pods.
I'm understanding that it simplifies network management and security across both type of workloads, right?
Yes, precisely, Bea. Because in this case, with that configuration, you can see that in the screenshot, we have VMs in the top screen, in the top part of the screenshot, connected to containers, and that kind of communication happens directly on the SDN, so on the software-defined network that is available for all the containers, and this allows us to configure also specific policies between pod to pod and vice versa. So VM to pod, pod to pod, VM to VM.
Good.
Now,
we have some questions here in the chat, but Fede, I think it's better just to cover the question after the presentation, right?
Yes, probably yes. I think that we will have, and I saw also that some questions are around migration. We will have a section around migration in some minutes. So we will probably answer directly from our presentation. Now, we mentioned the technology that is behind the virtualization, the Openshift virtualization, and this is KVM, so the Linux kernel hypervisor. KVM is a core component of Red Hat Enterprise Linux kernel. It has more than a decade, I would say even more, of usage in production in other products like the Red Hat OpenStack platform and the Red Hat virtualization.
We can see here simplicity in management, but I think that is important for reliability as well, right?
Yeah, exactly. This was the second takeaway from our previous discussion. So simplicity, reliability was the second. And indeed, KVM, QEMU, libvirt, which is the stack that builds up the Kubernetes and the Openshift virtualization stack, the Openshift virtualization software stack, leverages this mature technology. It's available on bare metal, on public clouds, and it has the Windows Server Virtualization Validation Program certification, so that we have compatibility also with the Windows Server guests, as I just showed in the short demo. This is the representation of that kind of stack, so the technology that we are introducing. On the left, you can see a previous implementation of the stack that was included in the Red Hat virtualization setup with the Red Hat virtualization host and the Red Hat virtualization management console. On the right on the right side of this slide, we can see an OpenStack environment with Nova as the main scheduler for compute resources. This is still alive. This is something that we still see as a requirement for some customers. But in the middle, we can see OpenShift Virtualization, KubeVirt, and the same components as an underlying stack. So libvirt, QEMU, KVM.
Wait, Fede. This means we are leveraging the Kubernetes control plane for virtual machines management.
Yes, that's the point. That you got exactly the point. In the end, we are using the kubelet that is working under the hood for every Kubernetes cluster that is working together with libvirt, the abstraction layer for virtualization, and QEMU KVM. And it manages VMs as they were containers. So this allows us to have declarative management, API for VMs. So we declare a VM with a specific API, and the ability to add virtualization-specific functionalities together with containers.
Amazing. So in the end, we are using the same hypervisor technology, well integrated into Rail kernel, just with a different abstraction layer. I assume this brings also benefits on the portability to virtual machines, right?
Yes, that's correct. That's perfectly the description. You made a perfect description of that, because in the end, we are using well-consolidated virtualization hypervisor capabilities like KVM and QEMU, and a new way to orchestrate them through the Kubernetes orchestrator. This is a brief example. We will not cover too many technical details today about the declarative API for VMs. This is a simple example. We can see that we can define a VM with a simple API following the API conventions from Kubernetes. So in the end, we will describe that kind of virtual machine in that way.
I love declarative APIs, honestly. But how does this simplify virtual machines provisioning for users?
Yeah, this is a key advantage again, because you can use declarative way to configure networking. You can see an example in the screenshot from the web virtual machine definition. You can use that for storage also, and in that way also storage is provided by storage classes. So something that OpenShift administrators are already providing to containers. Also, the customization via Cloud Init is inherited from this template, so you can easily script them and introduce them into the definition of the virtual machine itself. So in the end, the simplification is huge, because you can have a single template, you can customize templates, and you can define VMs coming out from templates and customize them further to suit your needs.
Really useful. Red Hat offers a robust set of tools for GitOps and infrastructure as a code. How we can apply these concepts just in the virtualization environment?
Yeah, this was the third point of our discussion, of our introduction. Indeed, the GitOps approach is inherited automatically from the OpenShift container platform. In this case, we are using OpenShift GitOps, which is based on Argo CD and is included in the OpenShift container platform. And we also have OpenShift pipelines that are based on Tecton to streamline the continuous integration of virtual machines. As an additional component, we also have the Ansible automation platform if we need a unified solution to combine also external, security and automation of external devices not included in the virtualization platform itself.
Great combination, GitOps and automation. So are those tools useful to scale up our automation workloads and workflow?
Yes, we can move further from the simple virtual machine creation that we saw in the demo some minutes ago, and we can apply GitOps approach to any sort of resource available in the OpenShift container platform, including VMs and its related artifacts. So for example, networks and storage. Also, an important thing that we are keeping all those definitions in a unique source of truth, which is our Git repository, that is constantly evaluated by Argo CD, by OpenShift GitOps, to apply continuous deployment practices and reconciliation loops. So the Argo CD continuously checks for alignment with what we define in our Git environment. In addition to that, we can also build pipelines with Openshift pipelines, which is based on the upstream Tecton project, to also offer continuous integration solution to our guests, to our virtual machine guests. So, for example, customizing templates, creating key pairs, executing specific commands on our platform. And last but not least, as we mentioned, the Ansible automation platform allows us to expand our coverage also to external entities like CMDBs, external network configurators, external monitoring platform, or backup services.
Good. And one question that sometimes customer asks me is that those tools are all included in OpenShift container platform in the offering, okay? And OpenShift Plus subscriptions, of course, to manage all our workloads, okay? So everything is in the same offering that we are having. Only Ansible automation platform requires a separate subscription based on the number of managed devices. So let's spend some words on it.
I think that you spotted right. And the great advantage is most of those features, apart from what you mentioned, or the Ansible automation platform, which is on a different subscription, are already included in the OpenShift container platform subscription. So in the end, you can add them whenever you need it. So for example, you can just add the relative operators. So for example, the OpenShift GitOps operator or the OpenShift pipelines operator to improve and augment your platform in case of such needs. I think that for this specific automation and infrastructure as code workflow, it's time to move on to another short demo time, presenting now an improvement to what we did earlier, and now letting Argo CD create the virtual machine for us instead of doing that manually by ourselves. Let's move on to the video for a second. I think that we are ready to run. And we can see that now we will deploy virtual machine through an infrastructure as code approach. We have some VMs described in our Git repository. And we can see here the description of the virtual machine, some details, for example, the number of cores and the amount of memory that we want to assign to each virtual machine. And we see now Argo CD that is ready to deploy. We are now syncing that manually. It could be automatic, of course, but for the sake of the demo, we are doing that manually. We are syncing the Argo CD. We are syncing Argo CD with the Git source. And as soon as Argo CD retrieves that there are some drifts, it will start creating the resources, as we can see here. So the virtual machine are going to be created, and all the depending resources are going to be created as well. So not only the virtual machine, but also the network and attachment and the storage requirement. And Argo CD will do the work for us. And we can see now that the virtual machine has been created on the platform. And so, for example, if we just select one of those two virtual machines that we described in our Argo CD definition, we can see the virtual machine up and running with the customization that we provided. So, for example, the cloud init to set up a username and a password to log in onto the virtual machine. And we can see now that the machine has also the networking correctly configured, and we can reach out to the external networks through the default egress endpoint. So this is an infrastructure as code approach to automate the creation and the management of our virtual machines.
So Ansible Automation Platform offers a wide range of capabilities to automate across your IT estate, okay? That is another story, okay? We will have another webinar about that, but tell me if it's true.
Yeah, probably yes. We will definitely need another webinar for that. But as we were mentioning, Ansible itself provides automation for all these kind of flows, including also external entities. So for example, we can have the same GitOps and DevOps approach, but also configuration management, network validation, orchestration of external components, and it will help the governance, the investigation, the incident response, the deployment. So for example, interacting with ticket services and CMDB services, and it will extend the security, the scalability, and the interoperability with all the elements in our data center.
The perfect combination, right?
Yes, indeed.
This slide illustrates a next generation approach to virtual machines provisioning. Imagine a request for a new virtual machine with a specific requirement like a CPU or memory, disk, operating system, additional file systems, and application platform details, including firewalls, rules, and DNS, and health check. Tell us a little bit more about it. Fede.
Yes, indeed. This approach, this new generation approach to VM provisioning handles all the automation to the virtual machine management and also to the entire process of a virtual machine. I think that this allows us to also deploy from to manage your network, storage, load balancer from code repositories, so to from a single point of single source of truth.
Fede, let's discuss about the challenges, because I'm certain that the path hasn't been entirely just straightforward. Could you elaborate, please, on the obstacles faced and the strategies we are employing to overcome this issues or problem that the customer sometimes is having?
Yeah, sure. Thanks, Bea, for the question. I think that the virtualization technology that we've demonstrated so far is very stable and reliable. But on the other hand, that is in the details, and our VMs require a lot of surrounding resources, namely network, storage, and a migration path from other platforms, as you saw some questions from the audience as well. So Openshift Virtualization offer some specific capabilities for our virtual machines. I will focus for a second on the networking side.
Yes.
The networking, our network virtual machines can optionally connect to the standard pod network, as we demonstrated in the previous demo, which is powered by OVN Kubernetes. But we can also add certified third-party CNI plugins like Calico from Tigera, Cilium, and Cisco ACI. And together with the Multus approach, we can support extra network interfaces, which are quite significant for telco use cases as well, supporting SRIOV, DPDK, and OVN secondary networks. In this way, we can also support multiple VLANs at fabric level that can be created or are already present in our data center, and we can propagate them to our internal namespaces of project. In this way, this is the most straightforward approach to VM migration, where we can simply extend the existing network to the new OCP nodes and create new VMs, or migrate the existing ones, and they can immediately access the entire network that we previously configured. Then after that, we can augment isolation through the usage of network policies. This is pretty useful, but we also went one step farther, and we introduced in Openshift 4.18 the native network isolation for namespaces, which is called the user-defined network, which offer a better solution from the monolithic layer 3 and layer 2 Kubernetes pod network.
This sounds like a significant improvement for multi-tenant environments, right?
Yes, because with the user-defined network, which extend the support of the single OVN Kubernetes network, in this way, we can have multiple isolated by default networks that can be assigned to one or more namespace. You can see that an example in the screenshot here, to each tenant. And a namespace can also be connected to virtual machine and to pods, so that we can have different UDN topologies, which are layer 2, layer 3, and local net. In this way, we also have overlapping IPs across different UDNs in our Kubernetes environment. And the user-defined networks also support network policies again, so that we can further customize the access to our resources and external services, and not only BGP.
Mm-hmm.
Now, another example of the networking configuration is also that we can leverage the existing Kubernetes load balancing service feature and also the service mesh. So that with service mesh, that is now fully integrated with Openshift Virtualization, we can provide a uniform way to connect, observe microservice-based application, and we can visualize and control the traffic between pods and virtual machines. This is a great advantage also for people that are running VMs but would like to start with service mesh technologies to monitor and observe the traffic. Mm-hmm. I think that we have a short demo.
This is the last demo? Is this the last demo? Because we are a little bit out of time.
Yes, you're right. We will be, well, this one is the shortest one. Then we will talk briefly about migration, but we can start with that one.
Perfect. Yeah.
Which is quite short and will tell us about VMs and how to expose services automatically from VMs. This is quite important because in that way we can create a well-known Kubernetes resource like a service mm-hmm. to expose a service, to expose a VM service out to the external network. In this case, we are exposing the cockpit management platform from a real virtual machine. We are creating the service, and after that, we are creating a route. In that way, we can expose our virtual machine through a well-known FQDN to our external platforms. In this way, we are also introducing TLS termination, so our traffic can be secured. And once we create our route, it is available and we can access from an external machine or an external bastion, our cockpit interface, and manage the virtual machine from a web user interface. This was very short, so that I think that we can move on to our last topic, well, our last couple of topics for today. The storage will be very quick, and we will talk a little about the container storage interface.
Yeah, tell us a little bit about the CSI, yes.
Yes, exactly. The container storage interface ensures the compatibility with all major storage vendors that have CSI compliant drivers. This is an example of some of the vendor, and in this way, we also support access to storage for our virtual machines within the OpenShift container platform. Those kind of providers also support accelerated cloning, for example, so that creation of virtual machine is very quick, also the backup or the snapshotting, and but we also have failback options for those activities that can rely on manual or internal activities from the Kubernetes platform to do, for example, disk resizing. We already delivered several POCs and pilots to customers with such storage vendors, integrating the existing storage on customer premises. For those who don't have an external solution available right now, we also provide a software-defined storage solution picked by Ceph, which is the OpenShift Data Foundation.
Good.
And just to briefly summarize the features that we have policy-based storage management that is available automatically from our platform through storage classes. In this way, we can also perform disks and VM snapshots, and also storage migration is supported. We can see here a brief table of the storage capabilities that are requested by our customer and how they've been implemented in OpenShift.
Yeah, let's move to the last point.
Yes, it's time to move to the last point for today, which is the migration.
A major concern for many organizations is how to migrate from the existing and current situation that they have with the virtual machines. Tell us a little bit more about it.
Yeah, thanks, Bea. This is where Migration Toolkit for Virtualization, or MTV, comes in. It's included, as the other products that we mentioned, in the OpenShift container platform, and it provides an easy-to-use user interface, also accessible through CLI and API, for mass migration of VMs from various sources, like VMware vSphere, Red Hat Virtualization, OpenStack, or other virtualization clusters that you may have, so that if you want to migrate from an existing OpenShift virtualization environment. As it happens for all our components, MTV is deployed through an operator, and it's a combination of different upstream projects like Velero and Forklift that allows the community to join the development of that kind of product.
And it's easy to use.
It's very easy to use. We saw MTV supporting mass migration. We've seen customers migrating around 6,000 VMs and running migrations in batches of hundreds to make end-to-end tests easier. VMs are converted in parallel at any time to maximize the throughput. And MTV can also support warm migration, which means that VM can be pre-copied before shutdown and to minimize the downtime. So only the delta will be copied while the machine is down. And also we can support dedicated network for the migration so that we avoid impacting other running workloads.
Good.
If we do that by extending the network, we get a machine that is able to migrate from one environment to another without even realizing that. So the virtual machine will start again and work. I think that it's time for our last demo. And while we are talking about migration, we will see a migration live. And we can see that we are starting from an existing VM in another virtualization provider, and we are getting ready to configure our MTV to migrate the VM, but also to define the storage migration and the network migration, because we have to define a mapping from the source networking to the target networking, and from the source storage to the target storage. We are doing that with the OpenShift Migration Toolkit for Virtualization that we will see in a second. From a specific namespace, we can see that it is installed and available as an operator. And in a second, we will see that configured. We will start with the provider selection so that the MTV can scrape our source provider to understand the virtual machines that can be accessed and that can be migrated. We provide the credentials there and the details to access the different virtualization source for our activity. After that, we are able to define the mapping for the storage and the network. We'll start with the network one. We can select all the networks that are present in our source provider and map them one by one to the target provider networks. In this short demo, we have just one source and one destination, so it will be pretty easy. But we can imagine that we can do with multiple networks as well. We will do the same with the storage. And again, we will see the storage, the data sources available from our source provider, and we map it with a storage class in our target provider. Once we do that, we are ready to create a plan to migrate our virtual machines. Yes, we are going to create a plan here. We are selecting the source provider, the target provider, and the target namespace to place our VMs in a predefined namespace. We are selecting the VMs, and then we are accepting the mapping that we configured beforehand. This is the network mapping, the storage mapping, and we are ready to go. We also have the possibility to run pre or post hook activities through Ansible playbooks if we need to customize our virtual machines before or after they are migrated. Once we do that, we are ready to go, and the plan will start.
Good.
And we are almost done with the migration. We just need some seconds for the plan to start. And after a while, we will see that our migration, of course, took some time.
Amazing.
Because we have to transfer the storage, but our virtual machines are now ready and available in our Openshift virtualization platform.
Good.
This was the longest demo for today.
Yeah, we have only just 3 minutes more, okay?
Yes.
But I need 2 minutes in order to talk about the services, because before just embarking on a migration, one assessment is crucial. Our virtual migration assessment is a structured approach that helps you to understand where you are and where you are going, and how to get together. So we have not a lot of time in order to go in details, but let me just tell you that the Red Hat services we cover with Openshift Virtualization Future conduct a deep dive into your virtual environment and analyze the integration for networking, storage, security, backup, and disaster recovery. So there are two in red. You can see just the strategy that is essential, and the foundation and expand, that is the migration factory that are being covered, yes, and are being offered. And optionally, you can just ask for a proof of concept, a proof of value, okay, one virtualization migration for a specific one application in order to prove the value. And you can just ask just application modernization, that is optional as well, in order to scale and evolve the solution, okay? So everything is covered by training and specific certification. But perhaps we have not enough time in order to talk in detail. If you are interested, just more than happy just to support with more info about the services that are essential when we are starting one journey. And only 1 minute more in order to cover the takeaways. If we did it well during this presentation, so I think we need just to know that the unified management of virtual machines and containers in Openshift are possible with Openshift Virtualization. Streamlining migration for virtual machines to containerized application are another key features and takeaway that we have to take here. We are able just to do faster production time with consistent development platform. We are just in an hybrid cloud supported, enable seamless virtual machines integration. So everything that we have from Openshift at this moment is valid just for virtual machines. And we have enhanced security with Openshift enterprise grade feature. Only 2 minutes, perhaps we can solve some questions, but if not, we will answer all the questions one by one, okay, just to you. So Fede, there was some question, for instance, from Farouk that was saying, is the standard CSI interface required for block storage access, and does it provide any limitation of storage-based replication or etc.?
Yes, I was trying to answer also on the chat, but we can answer that. We can take that one online. I think that here the main concept is the CSI interface provide different CSI providers provides different CSS capabilities. One of the requirements that we have for a CSI interface is that the storage provider has to be able to provide read-write many block storage for our virtual machines, because this allows us also to enable the live migration for VMware user. It is more or less the vMotion concept. and this relies on the availability of storage on all the nodes. So a read-write many capability is essential. And this also answers the question about migration.
Good. Mohammed was asking about the comparison about how it was doing in VMware, for instance. Okay, so he was asking, can we do a vMotion of virtual machines as in VMware is?
Exactly. This is exactly what I answered, and we can do live migration. It is called live migration, but we can do that. And the machine can migrate automatically, well, more or less automatically, or also triggered by a human intervention from one node to another. I think
and
that
it's
we also,
and it's possible to convert virtual machines to a pod and vice versa.
Yes, this is something that I replied in the chat as well. We have another product that can help. It is not a straightforward activity to convert VM to a pod, because you have to take into account some details of how your VM is configured, how your application is configured. To help this, we have another tool, which is called the Migration Toolkit for Applications, that helps you to transition from a legacy approach for your application to a cloud-native containerized approach. Maybe this would be another topic for another webinar next time.
For another webinar, right? Because Wilher was asking about the migration. When migrating using this tool, how do you handle disposing the services on the migrated VMs to the outside? He is asking, is automatic?
Yeah, that's right. This depends on how you're configuring your network. As we saw in the Migration Toolkit for Virtualization, you can map different networks from the source to the target provider. If you are using the same mapping, so if, for example, if you are exposing the same VLAN from one infrastructure to another, you will achieve the same network segment. You will reach the same network segments in the target provider itself. If you're using instead internal capabilities like the pod networking, then you can use internal load balancing services as the ones that we showed in our third demo, yes, to also have external access for our services within our virtual machine.
Amazing, Fede, the knowledge that you have.
We can just answer also the support for multi-tenant, the multi-tenant approach, and this is another yes, of course. All the things that we showed are done in what are so-called namespaces, which isolate VMs in different projects, in different groups of virtual machines.
Okay, good. Victor in the background is saying that we have to close the webinar, okay? So all the questions that were not answered will be just answered in offline. So thank you very much for your interest in this topic. Quite sure we need just 30 minutes more, okay? But thanks a lot just for this amazing interaction. And thank you very much, Fede, for sharing your knowledge and your expertise in the telco market with the virtualization. Thank you very much.
Thanks to you for being a great companion in our Openshift Virtualization tour. And thanks to all the audience.
Bye-bye. See you in the next webinar.